of AP 2003 free response problem. We'll start off in green this time. So it says if a cylinder develops a pinhole-sized leak and some of the gas mixture escapes, would the ratio of moles of nitrogen to moles of oxygen in this cylinder increase, decrease, or remain the same, and justify your answer? So what we're talking about with a pinhole-sized leak would be something called effusion. Okay, effusion is when something leaks out of another container, and what you need to know about, by the way, this is 10.8 in the book. That's section 10.8. And what you need to know about that is that the lighter molecular mass of gas effuses faster. Okay, we can go through the whole like root mean squared and all kinds of like calculus and math, but what we need to know though is that hydrogen gas is the lightest and effuses the quickest because it's only 2 grams per mole. And I know that from looking at the periodic table and finding out, like, obviously. So if I take a look at nitrogen gas, it is 28 grams per mole. And I know that oxygen gas is 32 grams per mole because I take the 14 times 2 for nitrogen and the 16 times 2 for oxygen. Now look at what we have for our equation. So what's going to escape the mixture faster, N2 or O2? And clearly it's going to be N2. N2 is on the top. This says our ratio is moles of N2 on top of our fraction over moles of O2. Well, over a period of time, there's going to be less N2 and more O2 because less of the O2 is going to escape. Okay, so that means that my whole ratio of N2 over O2 is going to decrease. It's not going to remain the same because not the same amount of gas of each one of those N2 and O2 are leaving at the same rate. They're not. The N2 is leaving quicker because it's smaller in molar mass. Okay, so that's the justification. N2 is smaller and effuses faster than O2. And that's it. All right, let's move on. So the next part to this then, of course, is a different rigid 5-liter cylinder contains 0.176 moles of NO at 298 and 0.176 moles of O2 are added to the cylinder where the reaction occurs to produce NO2. So what would that be? First part here is write the balanced equation. So that would be NO plus O2, and that reacts to form NO2, like that. These are all gases here. So how do I would think that I would put a 2 here to balance with a 2 here. That gives me 2 oxygens plus another 2 equals 4. 2 times 2 is 4, so that looks good to me. And this would all be, of course, gases, like this, like that. Okay, calculate the total pressure in atmospheres of the cylinder at 298 after the reaction is complete. Well, we're going to skip this problem for E because E ends up being something that we call an equilibrium problem. And we're not going to do an equilibrium problem. If you were to take AP Chemistry, you would see equilibrium problems and you would know why I'm skipping it and why it was a good idea to skip it. So we're going to skip letter E and just stick with D. That was easy, wasn't it? Wasn't that easy? All right.